Well, hi, and welcome to my shop this morning while I continue to work on this dastardly radio. Dastardly because someone else has done work in it, and it's really tough trying to trace through everything, that's for sure. So just before I turn the camera on, and not just before, I've been in here for about an hour verifying all this stuff against my ever so schmozzled up diagram here. Holy smokes. Yes, and the reason I've been so hesitant on this is there's an error up here, or so it appears to me. So I'm going to review it one more time. This will be like the 10th time I've run through this, and see if I end up once again concluding this capacitor is connected incorrectly. So the one place we can start here, which is very certainly, is on the back of this switch. And we can trace this wire, which is flying around, right up onto this terminal here, which is terminal number 1, 2, 3, 4, 5. 5 terminals in. Sorry for my diagram here. Please don't try to read it. 1, 2, 3, 4, 5 terminals in. Can you see in pencil? I have just penciled in this long running wire. There it is. Correct. Now, what else is hooked up to this terminal? One resistor there, R19. I have to look very, very carefully here. That's R19. And that's tied to this terminal. That's R19 tied to this terminal. How did I conclude this was done wrong? So, if we refer to the schematic, which I'm not going to put on the screen right now, it'll show that this terminal point, where this wire connects to this resistor, there should be a capacitor connecting to this point. Well, here's a capacitor connected to this point, but it's tied to this. This point needs a capacitor running down here. There it is. It doesn't need any others. What's this guy doing there? He's hooked up to the wrong spot. So in the radio, I mean, I'm not surprised the radio still worked like this. But who knows what that might introduce. Would it cause these resistors to get hot? I don't think so. I don't think that's related at all. Loss of volume, distortion, maybe things like that are more likely. So, and also, although I cleaned up this end of it, it was fairly easy. Cleaning this up, I think, involves removing everything from it and reinstalling everything new. That's all the resistors, everything, capacitors, the whole shot. And clean this up properly. So he's got a new resistor installed here. And you know, I was just on the verge of identifying that. Now this one comes, yeah, so I'm going to go back to proving that I understand what's there. Because, you know, once I strip all these parts away outside of the video and a photograph, this is what I've got to work from. Oh my gosh, so I'll probably have to redraw this again. I hope not. So, yeah, so I'm going to carry on and just prove out one or two more things here. Okay, so I've convinced myself I know what I'm doing. So I'm going to go ahead. I'm going to remove, this is my thinking anyway, I'll remove all the parts that are right up in here. I'll cut this lead, leave this part connected to where it's going. Likewise with this one, where it's going back into other circuits. I just leave it there for now, so I can't forget about it. Just bend it out of the way. And then I'll just start rebuilding this. I think I may even do the, yeah, I'm sure I'll replace this mic one also. May as well while I'm doing this. It's such a critical thing right here in terms of sound quality and other stuff because of the biasing effect of this capacitor. And I'll put this where it's supposed to be. I'll move this lead over, and and we'll see what we got when I'm all done. So, okay, that's what I'm gonna do. I'm gonna work on that today. As I cut away the parts in here, it gives me a chance to test them out of the circuit. So I've cut these two resistors free here, and we're going to test them. The first one is R19 and R19. Let me just be absolutely sure here so I don't make a mistake. R19 is supposed to be 100K. That's this one here. You can see my meter down below, which I cannot see. Hang on 1 second. Okay. What do you mean I can't see it? Just look down, Jim. Here we go. Instead of 100K, we get 150K. That's a 50% error. Now, the other resistor is supposed to be 650,000. And we can measure this one. I can see the colors too. Colors look more like 6. It looks like 68K to me, so it's measuring 1,000,000, and according to the schematic this should be 650. So out they come. As typically resistors tend to go high. I don't know if they can really short out as such. Away you go, yeah. Here we are. We're left with these guys here. Just coming off like that. Goodbye. Went for a fly. So this is the first mica. I take very few of these out, so we're going to test this one right now. Let's test it right now. Because often I say, hey, I'm going to do this or that, and then in the end I never get around to doing it. Let's do this right now. So I expect this capacitor to be perfectly fine. This is a 0.00025. Let's find out. I have great faith in this type of capacitor. I think most people doing this work do. I have found them shorted. Well, I have found one shorted that I can think of anyway. Okay, 50 volts. Let me get around here. Watching the eye. Oops. Good. Yeah, look at it. It's a tiny capacitor, so it charges up almost instantly. Boom. So we can put this right up to 250. Look at this guy. So as usual, this kind of capacitor shows no leakage at all. We'll measure its capacitance. It's very, very small. I said it was 0.00025. So it'll be on this scale. Okay, so we'll turn the knob now. Watch the eye. Oh, see the eye pop open? Quite distinctly right here. Right open too. So this is again suggesting this is a perfectly good capacitor. Now I would say, let's see, this is 0.0002. This is 0.0005. That could easily be 0.00025 right on the money right there. So not surprising, but I decided to replace it because it's just going to be difficult to kind of leave it in there and work around it. I'm going to be heating it up with a soldering iron and all that other stuff. So we got any other recent ones? Hey, how about this one? Let's go ahead and test this guy. So this is the incorrectly positioned one, an Astron. And I was thinking to myself, every capacitor in this radio has been a different make. Every one of them. Astron, 0.05. Now again, I expect this to test good. I'd be really surprised if this turns out to be bad. 50 volts, what can you do with it? 250 volts, yeah, it's testing just fine. Why don't we go ahead and we'll read the capacitance too. So that's going to be on this scale. Okay, let's go find it. There it is right there. And on the scale I'm on, which ends with 0.5, here we are. So it's reading just below 0.05. And it's 0.047 is what it actually says on it. So hey, not a good capacitor, but no problem. No problem, because the one I'm going to put in is even gooder than that one. Great. Now, let's what's left to cut out of here. So we have the long wire here. So this wire, it comes down and then it connects to this capacitor floating here. So I've realized, you know, during the time I've been working on it, that this capacitor was originally tied to this spare terminal down here, and the wire came down to the spare terminal. The wire is not long enough anymore. So the last repair just made it float. But I'm going to put it back on that terminal, or do something to get this problem out here. I'll just replace this wire when the time comes. Put a nice new wire in there. Put these out. I'm going to leave these two resistors connected. Maybe I should read them. Yeah, they're just proving two of them are bad. Let's check these two. And their values are, I don't know, I think it's 18 and 26 are the resistor numbers. So we'll just go right on the terminal here. Now on a 2 meg scale. Well, this looks like 68K, I would guess. So we're testing around 73K, okay. And the other one, it looks like red, it looks like a 27, looks like a 270K. We'll test that one. Oh, don't do that. 270, 370. Well, maybe that one's going to go too. Let's do them all. Do them all because I'm going to have trouble cleaning up these terminals if I have stuff connected to it. Off they come. Leave these hanging here so I can't forget about them again. And I have a capacitor hidden back here, which I put in, which I am going to take out. I'm going to sacrifice it. Poor guy. He did his job for a while. He kept things going. Can't remember why I changed this one. I'll just cut everything, Jim. First we'll cut away this big guy here. And we'll cut away here. Oh, the number of times I've just chopped parts out of a radio like this amounts to almost never. Almost never. And we're leaving these alone. We have a spare terminal in case I care to use it. Okay, she's cleaned up and hanging. So what I'm going to do now, I'm going to remove the solder from all these pins here. That's going to take a little while. I'll show you how I'm going to do it. I'll just melt it up. I have a solder sucker here. This is kind of a low-tech approach. Alright, you just melt the solder and put this up against it and go whoosh, and it sucks the solder up into it. I like that kind of tool. I have actually a solder sucking pump, but it comes with so many operational challenges when you use it. It's not worth the it's not worth it. So I'll use that plastic thing. We'll see what we get done here. Here, I'll let you watch me do the first one here. So my little soldering iron's not so good on such big stuff. I need patience. There we go. Let me get these wires off. Oh boy, that happened a little quicker than I expected. Okay, got them. Just get rid of some of the solder. There's a wire there still. I don't know if I got any that time. A little wee bit. This hole open and this little piece of wire off it. Get off. There it goes. That's one done. That's what I got to do to the rest of them. One by one. Okay, there we go. That wasn't nearly as bad as I kind of expected. So it's all cleaned up. Might still be a little hot here. Just feeling in behind for what I cannot see. looks good. So I'll just start remaking the component layout on here and get it ready for to be soldered up and finished. Okay, so I think I have all the parts installed now. I haven't soldered them yet, I just have them ready to go all in here. And so this capacitor was sitting in this position. This is a 0.05. On the schematic it's shown as a 0.1, and this was not connected properly. This was connected to the wrong terminal here. I'm quite certain of that. So I've done it according to the schematic. And also the switch here, you'll see most of the wires are gone from the back now. So what I've done with the switch is it's been a very simple thing to do. Just taking one wire off the back here and feeding it up through the radio, soldering it up here, and leaving this permanently disconnected means the expander circuit will be on all the time at this point. So that's how I dealt with this. So the switch will still stick out the front and be there, and you can turn the knob and all that kind of stuff, but expander circuit on all the time. Why not? Why would you ever want to actually turn it off? So, so I've got to solder all this stuff in here. That's going to be a little tricky. It's gotten a little busy up in here. That's what I'm going to do. And then after that, we're going to test this guy and see if it still works. That would be impressive if it still works. Okay, let's take a close look at my soldering here and see if we got everything soldered up. Okay, we're going to start down. Let's see, down in here. So I cleaned this up a little bit here. This is the new connection. Stabilizing this capacitor, and the new wire I put in, the yellow one, goes all the way up in the back and shows up right there. Doesn't look, yeah, I'm sure it's soldered. Okay, while we're looking at that, yeah, everybody's good there. Quite something to look at these up close like this after you do them. Everybody's solid. Now when I took this apart, this terminal just broke right off. There's no terminal, so that's just wire there, but that's okay. Okay, these ones. Probably throw a little more solder on there, but I think they're fine. I really do. Lots and lots of parts. Very good. Okay, I think we're all in business here. Now, didn't I also replace one of my own capacitors in here? One of them. I can't remember which one it was. I put in the wrong size. I discovered during all this analysis. Good. Great. I think it's time to try this guy out and see if it still works. So, wouldn't be surprised if it doesn't, having done that much work. Try as I may have introduced an error in there. So let's get this hooked up to our audio here. Wasn't it? So green was ground. Yellow is the signal. Okay, so that's going to pump the signal right into the sound you're listening to. Put on my headphones for this. Okay, now we still have the antenna connected. Pretty sure it's switched off back at the other end of my house. I don't think we're going to worry about it. Can I spin this way? Just because it's nicer to look at. Sort of nicer to look at. No, you know what? We should keep it back this way, because what I'm interested in is, are these resistors still hot? There, I just pulled off this. Are these, this one and this one, do they still get hot? And to check that, well, we're going to, here it is, here. Got it here. My thermal viewer. Get them ready. 80 at the top. Yeah, that's okay. We'll leave it like that. That's good. That's ready to go. Anything else here of concern? Not particularly. Volume control is turned down. Okay, I did a lot of work. As far as well, some of it was, I think some of it was dealing with B plus and stuff. So we're going to start out with full restriction here. Okay, is everybody ready? Is it plugged in? Yep, it's plugged in. Okay, so this first switch just arms my outlet. It doesn't actually turn power on. And this one selects down for the lights, up for Niagara Falls. Down for the lights. Here we go. Okay, it's behaving normal. Normally. That's good. Anything happening here quickly? Look quickly. Anything I did burning up? Nothing burning up. I thought I saw something down here already. I thought I saw something. Nope. Cool as a cucumber. Really? It's because I have this set to 80, so it takes something pretty hot, like this light bulb, to show up on it. Now, you know what's showing up? It's this meter here, which I left on all night. Yeah. The pilot light doesn't come on. Wow, okay, so this seems to have made a huge difference. These resistors are no longer hot. Let's give it the, I mean, what are we running with? We're probably running with only 50 volts here. Let's give it some more juice. Juice it up. Okay, I can hear, what you're hearing is an audible sound. I could hear this with my ears. Going in the microphone up here, which is just above the radio, coming from this replaced IF transformer. That's something to look into. It's still not getting hot. Look at that. This has made all the difference. Well, is it working? We don't know yet. I'll turn the volume up here a little bit. Wow, that's pretty quiet. Is that the volume? Did I really turn the volume up? Yes, I did. Let's turn it up a little higher. Oh. How about over here? It's working nicely. Okay. Sounds good. Sounds nice. I like it. Right now it's running with 100 volts on the outlet. I can't believe it just cooled these guys right off. Bingo. Did it really? Okay, so you can see some heat in this one. And that's 45. This used to be 65. It's 45 now. This one is just a little bit hotter. It's not quite 50. You can read the white number here as long as I aim this so that center plus, the white plus, is right on the object I'm interested in. Well, that made a difference, for sure. 50 degrees, I'm a lot more comfortable with that. 75, no. So I could put this on full, 120 volts. That would raise all the voltages in here and put more current through these and heat them up a bit. That would be a false thing to do, as was pointed out to me. I'd forgotten about the two 45s. We don't need to hear that. The two 45 tubes that I've kept out of this the whole time I'm working. With those tubes in, the B plus will be dragged down. So I was concerned about high B plus. I'd forgotten about the test I'd done earlier. So thank you very much, Mr. Viewer, for reminding me of that fact. We should tune this a little bit and see if we can hear anything. Oh, I think we're on the AM band. No idea where I'm tuning. Oh well. That's fine. That's fine for now. It's working. That's amazing. Got the power. That's nice how that fades out kind of slow too. So what's left here? Well, I pretty much removed... Oh, you know what's left? Test all those capacitors I took out. Yeah, so we'll start doing that in a moment. But I still have more capacitors that were put in by the last guy and more originals. There's an original here, I'm pretty sure. I've got to take a look at. And another rather curious thing I've discovered here. So this goes to the Magic Eye, which I have not had plugged in. And the wires come through up here. This is one of them here. This wire comes across and then just connects with a floating connection to this resistor here. Can you kind of see it? And it's a white, orange, green. That'd be like 93, 9. Yeah, when I'm really feeling stupid, I get this little card out here. And we dial them up. White, orange, green, which is really very unusual. White is 9, yeah. Orange is 3. 93. Wait a minute, I got the colors wrong. Yeah, white, orange, and then green. There we are. 9.3 million. So why this resistor is here, I don't know. It doesn't appear on the schematic. There is probably a 1,000,000 ohm resistor inside here. If you're thinking this one is the 1,000,000 ohm, it's not. So I got to investigate what's going on here. What is this all about? I don't know. So that's another thing to look at. I have this big capacitor, or this rugged looking capacitor here that needs to be sort of considered. I think there's a chance that's right across the power line. And then at that point, once I've kind of just cleaned this last little bit up, then it's a question of the radio's performance, its alignment, and then ultimately it's married up with its amplifier again and playing out of its own speaker in the cabinet behind me. And at that point, with any luck, we're done. But I don't know, there could be hums. There could be hums yet. Okay, so that's the plan going forward. A few more capacitors, and then we're back on the highway, so to speak. So thanks a lot for watching. And today, by the way, is the 1st of October. I may not get this posted till tomorrow, so which would be today, potentially. Figure that out. See ya.